Okay, good morning. Today we're going to combine two skills that we've already practiced, simplifying square roots with integers and simplifying square roots with variables. I've got two quick examples for you, just going to combine those two skills together. First off, I'm going to approach this problem simply with our factoring technique. So that's going to be the technique I use, is going to be our factoring technique. And I'll approach both the integer and the variable the same way. So what I really want to do is, like we did the other day, I can actually break that up into two different radicals, two different square roots being multiplied times each other, and then I can just treat them separately. So I'm simply going to treat the square root of 125 as my integers the other day. I'm going to treat the square root of n as my variable. So using my factoring technique, I know that 5 times 25 is 125, and then that 25 breaks down again into 5 times 5, and you can see 1, 2, 3, those are all prime numbers. So I'm going to go ahead and have those as the square root of 5 times 5 times 5. Now the n, remember when we did variables, what we did was we wrote it out in expanded form. Well, in this situation I've only got one of them, so there's not a lot to think about with that one. Remember, what I'm looking for are pairs. I have a pair of 5s right here, so I'm going to take that pair of 5 out and put it in the front. I have no pairs of n's, so there's nothing to circle there. So then I'm just going to have the square root of 5 here, and of course I have the square root of n. Now, why not put those both together and say the answer is 5 square root 5n. Alternatively, remember, some of us like to doing perfect squares. What I could do is I could break it down into 125 times the square root of n. So this is using our perfect square technique. Let's see, what perfect square goes into 125? Well, that's 25, so it's 25 times 5. And guess what? There still is no perfect square for this, so I'm just going to leave that as the square root of n. Now, because 25 is a perfect square, I'm going to go ahead and do that. The square root of 25 is 5. And just as before, these two are not perfect, so I will leave them as separate. And I hope you can see the similarities of where we were, but the answers are definitely the same. Now, this is doing the problem two different ways. Your choice, whichever way works the best for you. If you prefer the factoring way, then just ignore this way. And if you prefer the perfect square way, then ignore the factoring. We'll try another example. Okay, I'm going to give you a moment on your own to give this a try, and then we'll see if we get the same answer. Alright, so we're going to go from here. I think, because this number is so large, I really think I'm just going to stick with the factoring technique on this. Remember, I do have 512 and the k squared here. So I'm going to break down this 512. Let's see, it's an even number, so let's start with a 2. How about 2 times 256? That'll give me 512. Well, 256 is still even, so I'll go with another one. 2 times 128. Still even, so 2 times 64. Still even. 2 times, let's see, 32. Still even. 2 times 16. I'm definitely getting down there now. Let's see, how about 2 times 8? 2 times 4. And then finally, 2 times 2. Look at that. I had a whole bunch of prime factors. So all of those 2's together give me that 512. So remember what that looks like. Now the k's, remember, is just simply k times k. So I'm going to just put all of that together. I'm really looking at, how many do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 2's and 2 k's. And I'm looking for the pairs. How many pairs do I have? Let's see. If I have 9 2's, then I must have 4 pairs. 1, 2, 3, 4 pairs of 2's. And in this case, I have a pair of k's. So I'm going to take all those out. There's a 2. There's a 2. There's a 2. There's a 2. And there's a k. And what I have left out of all of that stuff that's left, that's only the 2 that's left. So 2 times 2 times 2 times 2 is 2 times 2 is 4, times 2 is 8, times 2 is 16, k radical 2.